One man has dedicated his life to studying these ecosystems, hoping to better understand them in order to protect them. For the past 60 years, botanist Francis Hallé has tirelessly explored our planet's tropical forests. He's spent a lifetime communicating with trees and immortalizing their amazing beauty on paper.
On my apartment's balcony in the Latin Quarter in Paris, I saw a plant growing in a flower pot. I did nothing to take care of it, but it continued to grow over months. It flowered, bore fruit, then seeds, and the next year its seedlings were sprouting everywhere. That seemed like magic to me. That plant showed me in one fell swoop everything that I think is magical about plants. They don't need us to care for them. They need us to leave them alone. And that's when I realized I wanted to be a botanist.
Today, Francis Hallé begins a new adventure in Gabon. It starts north of the capital of Libreville, at the Raponda Walker Arboretum. The botanist will then head south to meet his team at the Nionier Nature Reserve. Francis Hallé knew early on that he wanted to study the most inaccessible part of the tropical forest, its canopy. In the 1980s, the botanist was one of the first to explore the top of the trees, even though many scientists believed that the canopy held unique animal and vegetable life. But how could he access this elusive environment without damaging the trees or the life they sheltered? Always a poetic and prolific thinker, he set his mind on finding a way to reach the canopy from above.
Trees grow from the ground up to the canopy, so if we find them when they're little, we can study them before they're too tall. But that's not how it works for plants that don't grow on the ground. Some grow right on the canopy, creating these suspended gardens of orchids and ferns that are truly remarkable. I knew I had to find a way up there. I needed to see what was happening all the way up. It was quite an interesting adventure. I became friends with an architect, Gilles Ebersold, and a hot air balloon pilot, Danny Cléret-Marel, and we've been a team ever since.
That's how the Canopy raft came to be. A flying vehicle capable of placing scientists 60 meters in the air atop the tree canopy. An astonishing machine born from a limitless imagination and an unquenchable thirst for knowledge.
It would be great to land there, Danny. Later on, we won't be able to reposition ourselves.
It was difficult to pilot because it was a huge hot air-powered machine, the biggest in the world, carrying a canopy raft, which is a 600 square meter platform. That's a significant surface area. But on the other hand, it only weighs 600 kilograms. We landed on the canopy, and it covers about a dozen trees and 20-some vines. And it floats perfectly well, so we came up from the ground and had about 600 square meters of canopy at our disposal for as long as we wanted. It was absolutely amazing. It was an extremely fruitful period because everything we discovered there was new.
Francis, let's lift up the raft and then we can go.
From the dizzying heights of the treetops, Francis Hallé and his team discovered a fascinating universe. These air pioneers carried out incredible work and collected samples that were previously unheard of.
Here's something I've never seen. This might seem crazy, but it's a flax plant. In Europe, these plants are usually small herbs, but they grow into these incredible woody plants like this vine.
Safe travels.
Thanks.
Hasta la vista. Slow down. Otherwise, you'll have too much impulse and hit the trees.
From Madagascar to Cameroon, from Laos to French Guiana, for 30 years, the Canopy raft team has been perfecting techniques to explore the world's most inaccessible canopies. These aerial territories are home to nearly 3/4 of the world's insect life. The canopies of these tropical trees are also teeming with unique flora. Today, we consider the canopy to be the ultimate holder of our world's biodiversity. Now 83 years old, Francis Hallé never stopped chasing his dream of defying gravity. Each expedition is unique, and each canopy shelters its own biodiversity marvels. This year, a multidisciplinary team surrounds the botanist. Annick Schnitzler is a professor of vegetal ecology who specializes in vines. Danny Clayet-Marel is a famous canopy raft pilot. Benjamin Rebillon and Nui Bebin are both arborists, used to the most extreme expeditions. The group crosses the Gabon estuary to get to the protected forest in Nionier. The team decides to forge ahead to set up base camp and prepare their flight plan.
Here we go. It's going upwind because we're behind the ridge. Overall, it's very unstable. You can tell by its reaction. Now we're catching some wind.
Whoa!
To reach the treetops, Danny Clayet-Marel chose to use a cinébulle. Lightweight and easy to transport, this motorized 1,500 cubic meter hot air balloon can carry 2 people.
Let's try to avoid the gust.
Each flight requires rigorous planning. The pilot must analyze the airflow and the forest's unique air currents in order to ensure the mission is safe.
It looks good. Not too much wind.
No, I'm flying above it right now.
Gabon is an ideal place for studying the canopy. The country protects over 3 million hectares of forest, spread out over 13 national parks. It's home to some of our planet's very last primary tropical forests.
A primary forest is a forest that's never been cleared, cut down, or exploited. Well, it could have been, but enough time must have passed since then for the primary nature of the forest to reappear. It's a slow process. In tropical areas, forest exploitation leaves visible traces for around 7 centuries. The forest can only be called primary again after 7 centuries. But here, in the humid tropics, the trees grow all the time. If we were in Europe, we'd have to wait 10 centuries because the trees don't grow when the weather's not as nice. I've always been passionate about primary forests. The paradox is that whether it's Africa, the Americas, Asia, or Melanesia, these forests all share the same latitude, that of the equator. It's always the same big trees, the same light, sounds, smells, and it feels like you're in the same place. It's paradoxical because the continents have nothing in common. All their living beings are different, and so are the animals. The only animals that are the same are us, along with the animals that gravitate around humans, like lice or rats, which are everywhere.
North of Libreville, Francis Hallé meets his Gabonese botan friend Kevin Lekogo Kiana. He'll serve as a guide through this incredible site known as the Bois des Géants, or Giant Woods.
Wow. There. Francis, come see this. It's a long vine. It's really long. It's a kind of Bourbonnaise.
You recognize it?
Yes, it's beautiful. Let's see what... Wow.
A flower and a bud.
You really need to get up close to see it.
What's astonishing is that this plant doesn't undergo photosynthesis. It has no chlorophyll. It's completely white. We know how it gets its nourishment. It works in symbiosis with fungi.
I see.
The fungi absorb sugars from the tree roots and transfer them to this plant. A plant that survives off of its neighbor's sugar can never get too big.
It can't ask for more.
No. Oh, now that's interesting. What is that? Once again, we can see how the trees are in dialogue. I'm going to try and tell this story as I understand it. That tree was broken, and if nothing in particular had grown in front of it, it would have died, along with all its roots.
Exactly.
But as you can see, it's not dead. It has no leaves, so its energy must come from other trees.
Sure.
Well, these living trees transferred enough energy to allow it to heal. And what's good about healing is that the roots don't die. It sustains the life of the root system. Later on, this root system, which was kept alive, started working for the neighbors who saved it in the first place.
That's a nice way to communicate.
We should say that everything we know about trees is being completely revolutionized. We've started to reach the limit of what we understand about trees. This communication system, this dialogue that takes place is something completely new to us.
In the shade of these giants, the scientist takes notes in his botanical journal. Once the tree is identified, the botanist and the artist become one. Francis Hallé jots down his model's architecture.
I'm curious about the sheet. Why is it there?
A sheet in the forest is unusual.
It sure is.
It isolates the plant I'm interested in from the others in the background, which are less interesting. If I don't place the sheet there, all the leaves get tangled and this tree would get lost in the crowd. Look what it did. It grew straight up.
Yeah?
And the growing speed increased. When it reached maximum growth speed, which is several centimeters a day, it stopped on a dime. And it made 5 branches. We only see 4 here because one fell, but it grew a bunch of leaves and it stayed alive like that for years. Then, 2 or 3 years later, below the shelf, it grew a new trunk, which then grew beyond the shelf, faster and faster, until it was growing as fast as it could, and then boom, it stopped, and it grew 5 branches. and so on and so forth. The tree grows like that all the way up. This is just one architectural model. We know of 24 right now, which is not a lot.
That's not a lot.
There are some 350,000 flowering plant species, meaning many use the same model. This alternation of shelves and growth spurs allows it to overcome the harsh conditions in the forest.
They're competing for light.
Yes, exactly. This seems to indicate that there was an exploration stage. That's what we call it. Exploration, then exploitation.
We should verify that it's indeed part of the Fabaceae family.
Look, it's starting.
It's latex.
As soon as you break a vein, it excretes latex. Don't confuse it for sap.
It's an extremely powerful latex, very violent. It can make you go blind, so you need to handle it carefully.
It's a defense mechanism against parasites and predators.
The proof is that the leaf is in
Very good shape.
very good shape.
In the Neonier forest, Benjamin and Nui, the two climbing arborists, are getting ready to set up a platform at the top of a tree that's native to Gabon, an ukume. But before they can reach this giant's canopy, they need to carefully pass their ropes between the highest branches.
Here we go. And
It went through.
it's full of orchids. Francis will be happy. There's a lot of termites, too.
Nui and Francis Hallé go way back. This experienced climber has accompanied the scientist on numerous expeditions in almost all of the planet's tropical forests. 60 meters above ground, in a clatter of carabiners, the two arborists stabilize the watchtower that Francis will use for his upcoming observations. The mission preparations are almost complete. At base camp, the team reviews the mission's flight plan.
The wind will be more or less north-south. We'll have to manage the tides, too, which won't be easy. We'll be able to fly, but we might not get to do everything we want. Controlling the direction so that we can land on trees will be tricky.
After several hours of traveling through the forest, Francis Hallé meets up with the rest of the team. Jean-Paul Aragon, a traditional healer and medicinal plant expert, joins the expedition.
Lots of okome trees.
Yes.
It's a dominant species.
Even though he just got to the camp after a very long journey, Francis Hallé is impatient to fly over his favorite thing, the canopy.
How are you? Good to see you.
I hope we're flying tonight.
No. Wait. You'll see. We were talking about it. We can fly, that's not a problem. But it's the dry season, and there's a bit of wind, so it won't be all that easy. We did a first flight this morning to test it out, and it's fine. It's flying fine. I hope you're ready, because we set up a beautiful tree, an okume. We're going to spend the night in the hanging bed, which means we'll be able to try to set up a light trap. We'll eat and sleep up there till morning, because there might be great things to see in the morning, too.
After a short night, the team leaves before dawn to launch the cinébulle. In the early morning, the conditions seem perfect for the hot air balloon. The wind is calm, and the air seems stable.
A little more, and then we'll descend slowly to the ground. Now let's rotate. I'm attaching the ropes, and then you can go with the bag. 2 people. All good, you can go. Put your foot there. Hold on to this, never that. Make sure no one goes by. Francis, that should work, right?
I think so.
It's all hands on deck to set up the machine. The pilot starts to inflate the balloon using the motor that will allow him to steer the cinébulle. Next, the burner will create the hot air necessary for the flight and for keeping the balloon floating.
We're in a basin, so there's no wind at all. However, as soon as we get to the treetops,
It's moving.
there's some air moving from that direction, same direction as usual. Okay, let's go. There's a relief here, so there are downdrafts behind the trees, which means it's not reacting immediately. It's as if I pushed you, and that crushed you into the trees.
The cinébulle and the tropical forest are completely compatible. This machine was specially designed to explore the canopy. Francis Hallé savors this highly anticipated moment. But some days, it takes more than enthusiasm to tackle a dangerous flight. Francis thought he would be able to quietly collect canopy leaves. But Danny had warned him that in the dry season, the winds can be unpredictable. Our explorers are forced to quickly return to the ground before the balloon becomes incontrollable. The pilot's experience and composure are essential to safely land the hot air balloon.
It got windy as soon as we got there. I was aiming for the crest. Honestly, it's extremely unstable.
The aborted flight does nothing to quell Francis' motivation. While waiting for the conditions to improve, the botanist roams the forest on solid ground. Biologists long thought that the only way to identify a tree was by its leaves and fruit, a science developed by Swedish naturalist Carl von Linné in the 18th century. Francis Hallé was the first to propose a new methodology based on the various tree architectures.
When I was a student at the Sorbonne, they taught us that to identify plants, you needed their flowers and fruits, which date back to Linné in 1735. Linné focused all of botany on the study of flowers and fruits. So when I graduated from the Sorbonne, I was a Linnaean botanist. I got to equatorial Africa, took my first steps in the forest, and there were no flowers and no fruits. And we couldn't identify the trees of that forest, since there were no flowers or fruits. I'm so grateful for the help I got from a Baoulé chief in central Ivory Coast. We were in his village, and I asked him, "Chief, what do you call the big tree that I see over there?" And he said, "That's a framiret." I asked, "But how do you know it's a framiret? Have you seen its flowers?" And he started laughing. He said, "The framiret flowers? I don't give a damn about the flowers. I don't even know if framirets make flowers. We don't worry about the flowers. But you can tell it's a framiret. Just compare it to the abalé there, the dabema, the imian, etc. They're obviously different." That man was right. He was completely right. You don't need flowers. That's what architecture is. It's observing the shape of the plant. So far, we've discovered 24 growing architectures. Keep in mind that for animals, there's only one.
In 1970, when he was 32 years old, Francis Hallé published his first study on tree architecture. His pioneering work revolutionized botany. Based on his meticulous observations, the biologist revealed 24 architectural models around the world. Almost every tree systematically follows one of these morphologies.
This shape of plant has existed on our planet for 180 million years, long before flowering plants. In technical terms, we call this the roux model, which is quite simple, actually. You have a vertical trunk, which is obvious on the plant, and above the vertical trunk are horizontal branches that radiate around it. There are hundreds, if not thousands, of plants that follow the roux model, like the coffee bush, for example. These two things here are supernumerary trunks, and that's reiteration. Reiteration is when a young tree grows on an old tree. There are two here, one on the right and one on the left. It repeats the exact same architecture. Reiteration is really important because it signifies that a tree, like the Europhyllum, isn't a single individual, but a colony. This is a very young one, so it's easy to observe, but it will get big, and that's when there's so many reiterations that it becomes hard to see. You have to study the young ones like this. When you observe my Europhyllum, you can easily see that the old leaves have holes, like a sieve. That's typical of pioneer trees, which put all their energy into growing as fast as possible. They don't have much leftover energy to create the dissuasive molecules against herbivores, so they get eaten. The pioneer trees are always eaten like this. This is the opposite of the plants in a primary forest, which biochemically defend themselves much better.
When Francis Hallé goes to a tropical forest, he chooses a tree and gets out his pencil and paper. A photograph could immortalize what he sees in a split second, but he prefers to draw. It often takes him 3 hours to draw a tree.
Oh, it's complicated.
During that time, he has ample opportunity to ask himself questions while he studies his model. Botanist Anik Schnitzler gives him time to finish his sketch before accompanying him on the discovery of the vines of the underwood.
Anik, do you know the water vine?
No, but it's a big one.
It's beautiful.
Beautiful.
Tetracera grandifolia. It's a family we unfortunately don't have in Europe, Dilleniaceae, a tropical family, Tetracera, the water vine. It produces a lot of sap in its huge tubes, which are so big they don't have any capillaries. So if you cut it, it spills out. Here, take it. Drink from whatever side you want.
Okay, I'll try it.
When you're thirsty in the forest, it's a joy to stumble upon this plant.
Yes, it's delicious, very tannic.
I'm going to have a little.
Yeah. That's pretty crazy.
Of all the plant groups, this is the most important, the most interesting, and also the least well known.
What I find fascinating about vines is their sinuous nature. They climb on other things for support since they're not self-supporting. That's the essential nature of a vine.
If they don't have a supporting base, like this tree here, they can't grow. They stay on the ground and nothing good comes of that. They need a support base, and that's usually a tree, which naturally means they're much younger plants than the trees themselves. It's impossible to imagine a world where there were vines before there were trees. It wouldn't work. They spread across many trees simultaneously, right?
Yeah, despite the risk. If a branch breaks, it starts over.
That's why it's best to use multiple trees.
There are also some vines that adopt a single tree. In dark forests, they go for the biggest support base possible, one on which they can grow over centuries.
A simple wisteria, like those we have in France, can easily reach 150 meters. We measured the vines of rattan palms, 400 meters. And there's even talk about a vine that's a kilometer long.
Really?
In Comoro, I've seen a vine cross a valley and go down into another valley. But since they grow 40 meters above ground, it's very difficult to measure their length. To my knowledge, one of the characteristics of vines is that they have extremely deep root systems.
Yes, that's why they're not in competition with the supporting tree. They have a different kind of root system.
They don't waste any time or energy on making a hole, like this tree. And they have a vast surface area. So they have lots of energy available, and they don't use that energy to make a hole. They store that energy in very sophisticated molecules, which is why they have prodigiously powerful medicinal properties. They have a lot more active ingredients than trees.
Yeah.
Most of the people living in Africa depend on plants for healing. Tropical forests harbor an incredible diversity of molecules and are a genuine pharmacy for the locals. Before going up this Okume, Francis Hallé and Jean-Paul Aragon observe a plant widely used in traditional African medicine.
Superb, isn't it?
Yes.
It's the fourth largest family of flowering plants in terms of number of species, among which the coffee bush.
The coffee bush.
It's cinchona, a medicinal plant.
It's used in traditional medicine.
To fight what kind of ailments?
Hypertension and blood circulation.
More generally speaking, are Rubiaceae an important family in traditional pharmacopoeia?
They are indeed, because of their many active ingredients.
It's a vine that climbs to the top of big trees. What's great is how they attach themselves.
With hooks, yes. These are aggressive hooks.
They're hard. Great hooking system. When they find a support base, they harden and tighten. They're impossible to cut.
Especially when they're so close together. They tighten with each attachment.
Are you able to sit? I want to see how it is. Sit down. Is that okay?
Yes.
This is the safety rope, okay?
Okay.
It's a double safety. Good job. It's got some give. That's normal.
Every time I climb up into an equatorial canopy, I get this very strange sensation that I'm returning to my birthplace. Not my personal birthplace, the birthplace of the species that I'm part of. We're primates. Primates were born in the treetops. They're creatures of the canopy. I think it's possible that going into the canopy millions of years after the Homo genus appeared revives some ancient emotions within us. Many colleagues have had the impression that they're returning to the birthplace of their zoological species.
Hi, Francis.
Hi, Ben. It's very stimulating and powerful.
Can you help me pull slowly?
Yeah, sure.
More. Take a break. I'm gonna remove. Get in a comfortable position.
Counterweight ready.
Awesome. Okay, he's in the hanging bed.
Got it, Ben.
Good, that's great, Jean-Paul.
Gently, gently. Watch your head. Can you stand up on that branch?
I'll try.
As you climb, take the rope up with you. Pull that rope upwards, okay? There, you got it. Awesome. Francis is drawing. Great.
Francis Hallé was the first to suspect plants in the canopy had more complicated chemical molecules. Studies confirmed his intuition. A tree's medicinal properties are much more interesting at the top.
You know those ant colonies in South America that each carry leaf pieces?
Yes.
They take them into their massive underground nests. They climb to the top, take the leaves from the very top, then they go all the way down, which is an incredible journey for an ant. It proves that to ants, the leaves at the top are not the same as the leaves from the bottom.
That's essential in pharmacopoeia.
Chimpanzees had very elaborate medicinal practices that a mother passes on to her daughter, and so on. The animal can tell it's sick.
Sure.
And depending on how serious it is, it will collect leaves from the bottom, middle, or top. If it's very serious, they go to the top.
I think there's around 80 medicinal plants that chimpanzees still use.
Incredible. Now, the third component of the story. I was in a French Guiana forest camp in the rainy season, and we heard this great tree fall. The Guyanese people with me said, we're going to see the shaman. I asked why, and they said the leaves from the top of that tree were sought after by the shamans. With those three clues, the ants, the chimpanzees, and the shamans of Moroni, I knew there was more to this story. All this has been studied biochemically, and the active ingredients are between 4 to 5 times more numerous up top versus below. That means these forest treetops are an incredible medicinal resource. Another reason to pay attention to the canopies that surround us is that they're the liveliest places on Earth. They're home to the greatest terrestrial biodiversity on the planet, which is why it's so important to protect these forests. Unfortunately, it doesn't look good, because we're up against such financial interests that it's incredibly hard to even slow down deforestation. It's almost impossible. Human beings are not very smart. There, I said it.
We've got sandwiches. We have tomato and cucumber. Raw. Tomato and cucumber. Mr. Jean-Paul.
I suggest we install the sheet before it gets dark. We set it up and get the lights up. Once it's set up, then we can get ready for bed.
It's almost golden hour when the sun is deep.
Does this work?
That's not bad.
Take a look. I'll get off. Let's look at it suspended.
You need to hang it higher, though.
Okay.
As night falls, the sounds of the forest fauna come to life in song. Insects are attracted en masse to the light. Francis is not an entomologist, but he takes a liking to these modest creatures. Were it not for some of these pollinators, the forest would cease to exist. From the mushroom, to the elephant, to the ant, and the gorilla, every living organism contributes in one way or another to the equilibrium of the ecosystem. In this vast vegetal world, all the species are connected to one another. Over millions of years of evolution, this gigantic community gave life to the tropical forests. The wind finally dies down, giving Francis and Danny a chance to fly again in their mission to collect samples.
Beautiful, but we can't...
Let's not quibble.
I'll go up, that's not a problem.
The cinébulle is the only flying device that allows scientists to precisely select their trees. Coming from above, the men can safely reach the canopy and do so without harming the plants. Danny's expert hands navigate the hot air balloon to the tree that Francis has carefully chosen for his collecting.
We're going to bounce.
All good?
Yes, go ahead. Wait, let's try to...
Wow, look at these.
Oh yeah, they're gorgeous. Go ahead.
Oh, this one has flowers. A lot of them. I'll put them somewhere safe.
Can you get it in the bag?
Yes, careful. There's a nest of weaver ants.
Where?
There. Careful, ants.
I got some on me. They bite.
There's another one.
Oh, damn. And we got them all excited.
They're falling like rain. Be careful.
Let's try to go higher. Ugh, they're biting me all over.
When we disturb them, they fall from the nest.
Yes, I've got weaver ants everywhere. Hold this if you can. Ouch! The branch.
Careful, there's a nest there.
Look, they're all over me. Look, look!
A bunch of weaver ant nests.
Let's not stay in this tree too long.
Beware of the ants.
Holy shit! Sorry. You have some too?
Yes, between my fingers.
Up, up.
I was sitting on a nest, look.
Yeah.
Every flight and drawing give rise to new scientific considerations. For example, these giant tropical trees have surprisingly close genetic ties to plants thousands of kilometers away.
This might be surprising because we're in Gabon, but I wanted to start with gentians. I think these charming blue flowers are familiar to anyone in Europe, at least to anyone who frequents the alpine prairies. Gentians, like all living things, have ancestors. So, it's a legitimate question to wonder where the gentians' ancestors were from and what they could have looked like. It's obviously part of the plant's evolution. In the case of gentians, I think this okra resembles an ancestral gentian. I'm not saying this tree is the ancestor because gentians and okra were on the planet at the same time, and you can't live at the same time as your ancestors. Now that we have genetic studies for all of this, we can confirm that the ancestor of the European gentian was tropical, which logically means it was a tree. The genetic proximity is such that I believe we can assume that all of Europe's small herbs had forebearers that were great tropical trees. I also wanted to talk about another rather unexpected plant, nettle. Everyone knows the nettle we have in Europe. Every child has been stung by that plant. Well, like with the gentian, one has to wonder where nettle's ancestors are. Well, I'd like to introduce you to a plant that resembles what the ancestor must have looked like. The real ancestor disappeared long ago. You can take any small plant we have in Europe and find its tropical ancestor. This bothers some people, but we have to accept the fact that almost every European plant has a tropical ancestor, which means they originated in equatorial forests. When we analyze the genomes of the musanga and nettle, we can see they're the same. It's genetic proof these two plants are connected, despite the fact that they have very different characteristics and that they're found far away from each other.
A botanical researcher, but also a university professor, Francis Hallé has never stopped transmitting his passion and sharing his knowledge with young people. Students from Blaise Pascal High School in Libreville meet him while on break in Nyonye and pick his brain.
What do you think about man's impact on nature?
When I lived in Africa 40 years ago, there were forests everywhere, and now they're gone. That's what upsets me. That's man's impact, not climate change. Humans are going too far.
Do you think one day there'll be no more plants?
No, I don't think so. But if that ever happened, if there were no more plants, there would be no more humans either. We absolutely cannot live without plants. I would be horrified if we couldn't breathe anymore because we destroyed all our trees. Without trees, we can't breathe. It's the plants that give us the air we breathe. The solution is simple. We need to plant more trees. Now, if you had asked me whether the plants could survive without us, the answer is yes, of course.
Why do you love tropical forests?
Because what interests me is life. So I go where I can find the most life. That's why I've spent most of my time working in the canopy, the very top of the trees. It's for the same reason, because that's where you find the most life.
How long have you been doing this job?
I've been studying tropical plants for 60 years, and there are so many of them that I could never see them all in my lifetime. That's not even imaginable. I'd like to tell you something, my friends. We need botanists. I guarantee you that anyone who knows about plants and how to use them will always have a job.
Francis Hallé has dedicated his life to exploring the trees and studying the wonders of tropical forests. His scientific work has allowed us to better understand and admire the genius of the plant world so we can benefit from it, but also respect its fragility. The botanist hopes that a better understanding of the forests will draw attention to their beauty and raise awareness of the threats they now face. Conserving these precious troves of biodiversity is essential for the future of our planet. But will future generations take action before it's too late?